A few weeks ago, my daughter recommended the Akari puzzle to me. In this video, I will talk about the strategies I've been developing with some examples. First of all, thank you, daughter. Next, I give credit to Ashley, since my strategy is based on what is described in this article. Lastly, I highly recommend Ezra's channel here. So he's a fast thinker and fast solver who does live solving on a daily basis. Let's begin with some basics. Here are the corner rules, which are self-evident. There are some simple two-cell patterns, which are very easy to verify. Or you may pause the video if you have never seen some of them before. I'll come back later on these. The next important concept is hero survivor. Some Japanese solvers use rescue and self-rescue, something like that. Now, if a checked cell can be lit up by only one cell, I call this one a hero. For example, this is a hero to this cell. Or if an unchecked cell can only be lit up by itself, I call it a survivor. So this one is a survivor. And this one is both a survivor and a hero to this one. Well, actually, this one is also a survivor. Okay, now let's get to the core of the strategy. Well, let's start with one of the examples from Ashley. So here, we first circled it 3 numbered cells here, and they add up to 5. Then we draw exactly 5 red lines to cover all the neighbors of these yellow cells. And you can see that on each red line, there are at most 1 light bulb. The conclusion is then that each red line has exactly 1 light bulb, which is a neighbor to one of the 3 yellow cells. Therefore, we can check off all the cells on the red lines which is not a neighbor to any of the 3 yellow cells. Let's go finish the puzzle. One, two, three, four, 5. So in this red line, we see the bulb must be here. For other lines, we cannot decide right now, but we can see there's a 2. And we find a hero for this cell. 2, 2, 2, 1, 2, 2, 2. Okay. Now we go back and define our strategy. Notations first. So on the red line, the maximum number of bulbs is 1, like this one. On the pink, well, I prefer double red lines. The pink is what Ashley uses. There are at most 2 bulbs. You may ask why it's 2. This is because if we select these 2, right, these 2 cells, and if this one happens to be a bulb, then it counted twice because it's a shared neighbor of these 2s. On the white line, there's exactly 1 bulb, this one. On the green line, the minimum number of bulbs is 1, like here. So this one is red. And I also define a supercell, which is a combination of a number of unchecked cells. Usually it's 2. Like this one. And they are not adjacent to each other, this cell and this cell, but combined, they have exactly 1 bulb. We will understand it better with some examples. Well, you can see this one is also a supercell. Now to use this strategy, so step 1 is we select some numbered cells, mark them yellow, add the numbers together. Call it n. In this case, n is 5. And step 2 is draw red lines or double red lines to cover all the neighbors of the yellow cells. And if the total number of red lines is also n, then it implies that all red lines become white lines, which have exactly 1 cells each. Now, step 3, we can check off the cells from these lines, which are not neighbors to any of the yellow cells. Okay, let's start with, we'll look at more examples. Here you see, we select 1 and 2, a total of 3, and we have 3 red lines covering all the neighbors to this. Here, we first check off the corner, and then we see there's a supercell here, right? It's 1 supercell and 1 red line. This means we can check off, everything on this line except these 2. And in fact, if the light bulb is here, then this is a hero to this one. If the light bulb is here, then this is a hero to this one. Now here's an example of a rectangle, which is very common. So we select 4 cells, and they add up to 4. We have 4 red lines. Another rectangle. Well, the shape is a little weird because the selected yellow cells, they form a trapezoid. But then we have 4 lines. Here we have a total of 8 from the yellow, and there are 8 red lines. Now we solve these one by one. So we have 1, 2, 3. And here, 1 and 1. Oh. Now we look at these 2. Total of 4. 1, 2, 3, 4. We must have this here, this here. And check off these. Here, it's the same pattern as here, right? So 1 supercell here. So check off these. Now 2, 1, 1. Sorry, I shouldn't have checked off this one. So it's hero, corner, 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 corner. So 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1. Survival. Alright, next. So rectangle. 1, 2, 3, and 4. 2 here. Corner. 2, 1, 1, 1. Hero. Now this is a supercell of 1, right? So we cannot have this as a bulb. So it has to be checked off. 1, 1, 1, 1. Survivor, 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 survivor. Next. Rectangle. 1, 2, 3, and 4. Now look at this one. Here's 1 and 2. 2, 1. So it's one of these. Both names are not. Corner, hero, 1. One of these, 2, 1, 1, 1, 1, 1, 1, 1. Hero or survivor? 1. Survivor. Hero. Survivor. 1, 1, 1. Survivor. Hero. Survivor. Well, there's another way. We start from here. So this is a corner. And this is a supercell. But here actually we don't use lines. It's more like a casework. So this one, if this is above, then this is not. If this is above, this is not. So check it out. And then hero. 1, 2, 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1. So it's quite similar. 0, 1, survivor, 2, survivor, 1, survivor, 2, survivor. Next, we have a nested rectangle, 2 nested triangles. 1, 2, 3, 4, 5, 6, 7, 8, plus 2, 2, 1, 2, 2, 3, 4. Well, this is from yesterday. So here we have a slight variation of the strategy. Well, so after we check off these, we have 2 blue lines here. And then we select 1, 2, 3, 4, which is also a rectangle. But the total is 5 here, right? So we only have 4 red lines. And we haven't covered these 2 neighbors yet. That means the diagonal line here is a green. Because the total red line is only 4, but the total number of bulbs is at least 5. So this is a green line, which implies this is a red line, and green, red, red, green. And then, because of these are green, so this must be checked off. Survivor, survivor. 2, 2. Hero, 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 survivor, hero. Well, now we look at today's puzzle. So first of all, we can find easily 1 and 2, which is 3. 1, 2, 3. We can check off these. Now, this can only be saved by one of these. So these two form a supercell, and it's 1. Now we circle these 3 cells, a total of 4, and we have 1, 2, 3, 4 red lines. Okay, 1, 2, 3. Okay, 1, 2, 3, 4. Mm-hmm. 2, 3, 4. The good thing is we get rid of this one. Now the next step, you see, we have a white line here and a white line here. So we select these 3 with a total of 4, and we have 4 lines, 4 red lines here. Well, we can also eliminate this one. So, okay, now we have a supercell here, because this has to be rescued or saved by one of these. 1, 2, 3, 4. 1, 2, 3, 4. See here? So we eliminate 1, 2, 3, 4. Yeah, this can be eliminated, because we only look at these 3, not this. 1, 2, 3. Remember, this is a white line already, right? We look at 1, 2, 1, 2, 3, 4. So this is a white line. There can be only one light bulb. It has to be this one. Now 1, 2, 1, 2, we're done. Alright, now let's go back and look at some of the simple patterns. So here are the color rules. Now we use lines to decide. So here we have a white line here, or supercell, well, which means this cannot be a bulb. And here, this is red, then this is green. And this cannot be a light bulb. For 3, we have 1 red, so this is green. And then this one cannot be a light bulb. So actually we have a general corner rule. So if a diagonal is a white line or a green line, so this corner cannot be a light bulb. So in fact, this need not to be 45 degrees. It can be any shape, any slope. Now the 2-cell patterns. So here, we only look at 2 here. This one is red. So this one must be green, so it's a light bulb. Here we have a double red line here. So we have a total of 1, 2, 3, 4, and 5, 6. So if this is a bulb, that removes 1, 2, 3. We're left with only 3, which is impossible. So this needs to be checked off. And here we have a total of 5 lines. So if this is a light bulb, then we remove 2 of them, left with 3, which is insufficient. And here, 3 and 3, we have 6 red lines, and 6 total. So this one has to be selected. Alright, thanks for watching.